So the last thing we're going to look at is tangential and normal components. This is still curvilinear motion. We have normal and tangential components. And with this, we basically have a particle, and we have the tangential acceleration is tangential to that path, so a sub t. And then the normal acceleration is towards the center of that curve. And that curve, that radius there is rho, and the velocity is moving along that path. So the velocity for this equals the velocity times that unit vector in the tangential direction. So that's just telling us that the velocity is all in that direction, in that tangential. So the velocity is tangential to the path. And then we can do the acceleration is dv dt, so the derivative of velocity with respect to time. And that's going to equal d dt of v times that unit vector in the tangential direction. And then we can basically do some sort of simplifying that. So taking the derivative of the velocity times ut plus the velocity times the du dt. So maybe I'm going to do a little bit of an abbreviated one. You can see the whole thing in the whole derivation in your textbook. So a equals dv dt times ut plus v times du of t dt. And basically what you can do is, I'm not going to go through this, but you can take this down and it's basically equivalent to, let's see, sorry, not that whole thing. Making this a mess. Let's see, I'm going to write it again. So that du sub t dt equals equals u sub n times 1 over rho times v. So that equals v over rho times u sub n. And so now we're just going to, and I could have showed you the whole derivation, but I'm not going to do that now. We're basically just going to substitute this back into here, and we get that acceleration equals dv dt times u sub t, or in that unit vector in the tangential direction, plus, and then v squared over rho times u sub n. So basically, that's what the acceleration is. So acceleration equals that acceleration in the tangential direction times u sub t plus that acceleration in the normal direction times u sub n. And these are perpendicular to each other, so that magnitude of A equals the square root of a t squared plus a n squared. And I think that's it, just to sort of reiterate what we see right here. So that a sub t equals dv dt, and that a sub n equals v squared over rho. So those will be the main things that we need for this. So here's the main equation. They're perpendicular to one another, and then here's just the breakdown of the normal and tangential acceleration.